Hello everyone, this is uh, 2018 paper 2 question 3. Now it is a vectors question, and when I look at the big picture, looks like we are looking at coordinate of the Cartesian equation of a face. A face is like a plane, a side. We are looking at angle between the base and BC, so angle between two planes, and shortest distance between midpoint, etc. So okay, it is equation of a plane. Sorry, it is a question on vectors. Okay, most likely plane. Okay, so I just scanned through the whole question. Now, an oblique pyramid has a plane base ABCD in the shape of a parallelogram. Now, very important, okay? You need to be very clear. When it is parallelogram, square or rectangle, opposite sides, right, are equal. But when we look at vectors, we call them equal vectors. So here we can be using, we can use equality of vectors concept, okay? So I'm not sure whether in this question, but we look at it. So remember, now trapezium, you can't do that, okay? Because opposite sides need not be equal, therefore the vectors are not equal. Yeah, they are parallel maybe for one side, okay? But here we're looking at parallelogram. Now the coordinate of A, B, and C are given. So when you look at the diagram, you will realize there's an origin, okay, somewhere here. So we have X, Y, and Z axis. So you have an origin, and yeah, okay. The apex is E0010. So 0010, it looks like it is on the Z axis, which is also in the diagram. Now find the coordinate of D. Now, if I look at D is one of the coordinate in the parallelogram, one of the vertices. So I can use equality of vectors over here. So now, in this case, I want to use vectors AD. Vector AD is equal to vector BC. Okay, remember the direction A to D should be equal to B to C. You can't use AD is equal to CB. You can't, okay? It should be in the same direction. All right. So I'm going to write down quickly. So this one, I think you should be able to do it. So part one, using AD vector is equal to BC vector. So I'm going to use, I will use AD is OD minus OA equal to OC minus OB. So my aim is to find OD. So OD will be OC minus OB plus OA. I think you know each of the coordinates. So therefore you can write them as position vectors, which is negative 5, 4, 2 minus 5, 4, 0 plus 5, negative 4 and 1. Okay, so this is a plus over here, and this one overall it will give you negative 5, 4, negative 4 and 3. So therefore the coordinate, remember the question asked for coordinate, not position vector. So D is negative 5, negative 4 and 3. Okay, you must give, this is important, you must give answer in coordinate form, answer the question, right? Now looking at part 2, find the Cartesian equation of face BCE. Face BCE is a triangle BCE, and if you need to find the equation of this plane, okay, of this surface, it is actually a plane, okay. And to find equation of a plane, you need to actually obtain what is a normal and yeah, any point on the plane. So in this case, I don't know the normal, but I can find it. Okay, I can find it. I can take the cross product of two vectors. For example, I can use EC, maybe EC cross with vector EB. I'll get my normal. Okay, so I'll do that. Okay, I'm going to write it on the right here. Now, I want to find the normal of that plane. So therefore, I will use EC and EB. So my EC vector will become OC minus OE, which is negative 5, 4, 2 minus 0, 0, 10. The answer is negative 5, 4, and negative 8. And similarly, I'm going to use EB. It can be any two vectors. I'm using EC and EB because I know the coordinates. You can use any other two vectors, okay? 5, 4, 0, 0, 0, 10. So it is OB minus OE. This will be 5, 4, and negative 10. Now, my normal of plane, okay, I will not write it yet, okay? I'll tell you why. Let me first do the cross product. EC cross with EB first. Because sometimes, right, after you do cross product, you may want to use a simplified vector as a normal. So that's why I don't want to write the normal yet. So I just do EC cross with EB. If I do that, is negative 5, 4, negative 8, cross with 5, 4, negative 10. Of course, I use EC cross EB. You can use EB cross EC, it's the same, okay? You will get opposite answer with a negative, okay, for each term, but it doesn't matter here, okay? So when you do that, you hide the first row, and then you do a shoelace, okay? So it will be, I think I don't want to talk too much about it. I think the formula is also given in formula booklet. Your answer here will be negative 8, negative 90, and negative 40, okay? Now, one thing I will want you to know, always check, okay? Always check. Let me use negative 8, negative 90, and negative 40. And if I dot with any of the answer, negative, any of the vectors, negative 5, 4, negative 8, you will realize you will get 40 plus 360 plus 320. Oh, it is 0. So therefore, my cross product is correct. Always remember to check, because there's no point if your cross product is wrong, then everything will be wrong. Okay, so there's an easy way of checking it. So your answer, you dot with any of the two vectors used to find that to do the cross product. Okay, because the normal is always going to be perpendicular to each of the vectors. Okay, now, so now I'm going to write, therefore, normal of plane BCE, okay, of plane BCE, use a simplified form. So over here, I know I can factorize out a negative 2, and I'll get a 4, 45, and 20. So I will use 4, 45, and 20, a simplified form, because it just makes the subsequent working easier. So I repeat that. The normal of plane BC, it can be a simplified form of the cross product you obtain. So therefore, the equation of the plane, so I'm going to use a formula, R dot with 4, 45, 20 equal to any point on the plane. I can use 0, 0, 10, because E, right? 0, 0, 10. It is easy for me. A dot N. So 4, 45, and 20. If I do that, I'll get R dot with 4, 45, 20 equal to 200. Now, the question did not ask for just equation of a plane. What we obtain here is a scalar product form. It's not the Cartesian form. So look out for things like this. So the question asks for a Cartesian form. So the Cartesian equation, okay? So Cartesian equation of plane will be, so you're replacing the r by x, y, z. So it is 4x plus 45y plus 20z equal to 200. This is your final answer. Right, so now we're going to part 3. Find the equation, find the angle between face BC, which is plane BC, the yellow triangle, and the base of the plane. So, and this base of the plane is a rectangle. So yeah, it is a parallelogram. Now, angle between these two. So it's just finding the angle between two planes. And to find angle between two planes, we are going to use, okay, we're going to use cosine theta equal to, did you say acute angle? Okay, so did that same thing. N1 dot N2 over modulus N1 modulus N2. Okay, so to find angle between two planes, we use cosine formula, cosine theta. Okay, so of course the question did not say acute angle, but most likely the answer you obtain will be acute. Okay, and anyway, in exam it is all right, because angle between two plane can be obtuse or acute, but we always look for the acute angle. Okay, so actually you can put a modulus here. So now, finding angle between two plane, you will use the two normals. I know the normal for plane BC from part 2, but I don't know the normal for the base of the pyramid. And I want to tell you, don't be deceived by this diagram. In the diagram, it looks like the parallelogram is on the base. Okay, sorry, it is on the xy plane. Actually, it is not. Okay, it is not on the xy plane. So perhaps you need to find the normal of that plane first. Normal of that base. Normal of plane ABCD. So I want to be very clear. Don't be deceived by this. Okay, so let me do the working. Okay, I will click at the bottom here. So part 3. So right now, you want to find the normal of the base because you need the normals. So I'm going to use the vectors AB and AC, AB and BC, and then I'm going to cross the two vectors to obtain the normal. Okay, so I'm going to write AB vector will be OB minus OA. I'm not sure whether we found it earlier. 540 minus 5, negative 4, 1. So it is 0, 8, and negative 1. And I'm also going to find BC, which will be OC minus OB, so which is negative 5, 4, and 2, minus 5, 4, and 0. So I will get negative 10, 0, and 2. Now, I'm going to find AB cross with BC because I want to obtain the normal of that plane ABCD, the base. So it will be 0, 8, negative 1 cross with BC will be negative 10, 0, 2. I will get 16, 10, and 80. Okay, so you can test out. I was just doing a dot product, and yeah, it is correct. Indeed, it is 0. Okay, so check. You don't need to write it. I just dot with negative 10, 0, and 2. I get negative 160 plus 160 is 0. Okay, good. So done. But I want you to take note because we always want to work with simpler, smaller numbers. So over here, I can factorize out a 2 or negative, okay, yeah, a 2. I get 8, 5, and 40. So I can use 8, 5, 40 as a normal. Okay, so I'm going to write it here. Therefore, normal vector of the base of the pyramid is 8, 5, and 40. So in exam, right, don't just anyhow use theta. Okay, always when you're finding angle, quite often we just use cosine theta. Okay, but what is a theta? You need to define it. So let's define theta first. Let the angle between the planes be theta. Now I can easily use cosine theta equal to, of course, I'm going to use n1 dot n2, so which is 8, 5, 40 dot with 4, 45, and 20 from the previous part over square root of, okay, I use a calculator, 8 square, 8 square plus 5 square plus 40 square times 4 square plus 45 square plus 20 square, and all this in modulus. Actually, yeah, the numerator was still positive. Okay, you will get 1057 over 1689 square root 2441. So therefore, your theta become cosine inverse. So 58.6 degrees to 1 decimal place. Remember, angle in degrees is always 1 dp unless the question asks otherwise. Okay, so this is finding the angle between two planes. So this completes part 3. Just a quick one. Angle between two lines. Okay, if you want to find angle between two lines, you always use cosine theta formula. If you want to find angle between two planes, also use cosine theta formula, but of course use normal here. For lines, you use direction vector. But if you need to find angle between a line and a plane, always use sine theta. Okay, sine theta equal to n dot d over modulus n modulus d. Okay, so refer to your notes for clarification. Okay, all right, so now we look at part 4. Part 4 is find the shortest distance from the midpoint of edge AD to face BCE. Oh, so it is finding the shortest distance between a point and a plane. Okay, I'm going to just draw a quick, okay, I will just use a diagram given. So let me just clean it up a bit. So now we're looking at the shortest distance between the midpoint of AD. So let me call midpoint as M and the plane, okay, midpoint and the plane. So the plane is the triangle. So the shortest distance will be somewhere like this, maybe around here and like this, okay. Now I'm going to just rewrite it, redraw it. So if this is a point M here and this is a plane, okay, a plane that has 3 points, maybe I have my E somewhere, my B somewhere, and maybe my C is here, okay. If I want to find the shortest distance between M to this plane, the concept I can use is, if I know any vector between this point M and the plane, for example, I actually know this vector ME, I can project ME on the normal, on this vector, on this normal, the normal of that plane BCE. If I project ME on the normal of the plane BCE, I will be able to find the shortest distance. Okay, so the theory is length of projection, project ME on the normal of plane BCE. Okay, I'm just redrawing the diagram on the right. So let's focus. Find ME, vector ME, and we already know the normal. Here, I think the normal was 4, 45, and 20. So project ME on that plane. So basically it will become length of projection is A dot B cap M dot with 4, 45, 20 over the modulus of B, ME dot with N cap. So length of projection of a vector on another vector is always dot product. Okay, I always tell you all this. So if you want to project ME on this vector, vector on vector is always dot product. So it is ME dot with N cap in this case. So I'm just writing it ME dot with N cap, which is ME dot with 4, 45, 20. So of course length is modulus over square root of 4 square plus 45 square plus 20 square. So this is a plan. Okay, I repeat in exam you need to plan it before you do it. So let me just work out everything. I need to also find what is OM, because M is a midpoint, right? So I will use this space here. So quickly, okay, we need to give it a name. So part 4, let M be the midpoint of AD. So okay, it's the presentation that is expected. So your OM will become actually OA plus OD. Okay, is it AD? Yeah, OD divided by 2, which will be 5, negative 4, 1 plus negative 5, negative 4, 3 over 2, which is 0, negative 4, 2. Done. That's your OM. So I need to find ME, which is OE minus OM, which is 0, 0, 0, 10. Okay, I'm using OE because it is easy number, 0, 0, 10. It is less prone to carelessness. Okay, we have 0, 4, 8, that is ME. So now we're looking for distance. So therefore, distance from, is it just distance? It is a shortest distance. It is actually, write your thoughts, length or projection of ME on 4, 45, and 20. So the examiner knows what you're going to do. So it will be ME dot with 4, 45, and 20 over, I think we have already calculated, this one was 2441 from previous part. 4 square plus 45 square plus 20 square. Okay, this is all in modulus. So it is 0, 4, 8, 4, 45, 20. Okay, this should be 340, 340 over which will give me 6.88 units because you're finding length. So this is to three significant figures. All right. So remember how I plan it, and I look at the main concept, which is just finding distance, the shortest distance between a point and a plane, and you can use length of projection. Okay. So that's all for this question. Thank you very much.